And I will super quickly jump to our next speaker, to Daniel. And I'm sure that you enjoy his presentation as well. Thank you so much for coming here today. Daniel also has some cool stories. He'll talk about abusing postMessage API for 6 figures a year. His talk highlights several vulnerabilities that were found during the past years, many of which could have affected millions of people. It's a story about big bounties and not very fixable vulnerabilities, as he puts it. Daniel, the floor is yours.
Well, first of all, thank you, Colin, for a very good presentation. I will try to speed up at least my presentation since we are a bit late. And as you mentioned, today I will be speaking about how we can abuse the postMessage API in bug bounty programs. About me, I'm an ethical hacker working with a team of KPMG Romania for more than 7 years now. I am interested in everything that is cyber related, but for the purpose of this presentation, I will be focusing on bug bounties. And when I say that I'm a bug bounty hunter, I really mean that I'm trying to hunt for big vulnerabilities. But as you can see, I don't know what's happening, so I tend to skip on RCs and other cool stuff, and I only find cross-site scriptings. But yeah, let's make the most of it. In this presentation, we'll touch a bit of theory regarding postMessage, but not too much, not to bore you. We'll see a bit, a few ideas which can help us to discover more riskier vulnerabilities, and a number of actual vulnerabilities that were found in the past year. Some of them were paid, others were not, and in the end, we'll see a few vulnerabilities that paid quite well. Well, I hope that you are comfortable reading JavaScript code, because if you are not, then you will have a hard time during this presentation. The only slide for theory, I promise. Postmessage vulnerabilities basically have 2 components. The first one would be the event listener, which can be put on any window in a browser. This event listener, as you can see, can verify that the message received is from a trusted origin or from a trusted source, a trusted window. And if the validation is performed at all and is correct, then you can process the event data for any purpose that you wish. In order to trigger such an event, you have to post a message to a target window. You need this window handle, and you have to send a message in a correct structure. A few tips and tricks. As I mentioned, you can find postMessage vulnerabilities on any window. Right, you are not navigating to a website, but you still see postMessage event listeners being present here. And when I mean any window, I really mean any window. For example, in the second screenshot, we can see that an iframe within this page has its own postMessage event listener, right? So it's important to remember this, that iframes can have different event listeners than the parent window. When trying to trigger such an event, as I mentioned, we have to know the target window, which one is it, and we can obtain this in JavaScript in a number of ways, but my preferred for a proof of concept would be to use a window.opener one. You can obtain a window handle by any other mean, but you have to have a valid window handle. Other than that, when sending a message, it is important to know what structure that message is expected to be. Should it be a JSON? Should it be a string formatted in a special way? And in order to have the message accepted, you have to bypass any check that is in place. For example, you have to send a message from a trusted source, or to be one of the trusted origins, right? Where exactly do we find high impact vulnerabilities? Well, I try to search for such vulnerabilities in applications which have lots of functionalities. The more functionalities, the better. And where some cross-domain communication is needed. And from experience, I can say that I've seen such communication in lots of websites which implement chat functionalities, chat support. We have this in payment flows. If the payment is opening in a new window, or if it is embedded in our page in an iframe. We have it in login flows, and in any case where iframes are used, right? So okay, let's just see some examples to better understand this. The first warm-up vulnerability, we can see the event listener, which tries to get the FN from a window property. The event data callback, the event data is the message that we sent, and the callback is probably a part of the JSON object that we sent. And yeah, if this FN exists and it is a function, then this function will execute part of our message again. So how can we trigger this for exploit this for triggering cross-site scripting? Something like this. We have to get a handle of this window, and after that we send a post message with the following JSON. The callback parameter could be the eval function, and the param parameter could be any JavaScript code, and there's that. Okay, I know what you're thinking. This is still theory. There is no way this is anywhere out there in real world. But the sad truth is that this vulnerability is affecting a Romanian company, one that I'm a customer of. This company has no bug bounty program, but they are as big as they can get, and they have the resources, they have the know-how for fixing this vulnerability, but they are not doing so. I don't know why. Please, guys, if you're seeing this, try to fix it. It's affecting my account, please. Yeah, I reported it to them more than 1 year ago, and still no fixing, but who knows, maybe. Let's see some vulnerabilities that actually pay for their discovery. The first example, and this will be the only example where I give the company's name. This one is in Mozilla Foundation. They used to register a post-message event listener on a page where they were expecting comments from users, and this message did not. This event listener did not check in any way the origin or the source of the receiving message, but they did check for the message itself to be in a specific format. Maybe if I can zoom in a little. They were validating the data to follow a specific regex, which is not that complicated. It has to have a few letters between parameters, and that's it. So yeah, there was a origin check in place, but they were accepting messages from any domain, from start, so any domain. That was not really a problem. Probably it was misconfigured or remaining from a test environment. I don't know. While processing the received message, you could end up in multiple other functions, in functions that could handle this event. I went through all of them. Most of the functions do a lot of stuff with your message, but there was no redirecting there, no cross-site scripting, no nothing, except for the navigate function, where I think I got lucky. Because if we look at the navigate function, we can see that it uses part of the received message in order to open a new window. In this case, if the window is pointing towards a JavaScript URL, then we will have a process scripting vulnerability. The proof of concept for this vulnerability is rather straightforward. We open the vulnerable page in a new tab for obtaining that window handle that we need. And after a few seconds, after the page loads, we send the post message in a format that would be accepted, right? To bypass that regex validation. Mozilla is pretty cool with their bug bounty program. They try to pay for everything that is needed. This was not necessarily a payable vulnerability on their side, but they did try to pay for it. A 3 digits bounty, which is pretty cool. Yay! Let's move forward. The second vulnerability, this one is slightly more complicated. In this case, we can see that, well, it's part of the event listener, but in this part of the event listener, we can see that they try to validate the origin of the receiving message. It's just that they do it in an incorrect way. For example, in this case, they try to see if our domain is contained within a whitelist of their own. Their whitelisted domain was something like very trusted.domain.com, which is an incorrect mode of validating the origin, because it also validates the very trusted.do domain, right? And what I did, I registered that domain. It was available. Okay, this is a demo, not really very trusted, but another name. This domain was available, so I bypassed the origin checking this way. This is only the first part. The second part would be to actually find the DOM process scripting vulnerability within the listener or any other vulnerability. So was there any? Yeah, there was. In this case, you can see that again, the user is redirected to part of the message. And if this part of the message would be a JavaScript URL, then again, we would have a process scripting vulnerability. And again, another part of the event listener would do something very similar. And another one would construct a model window using part of the message as a URL. So we had multiple ways to trigger the XSS. And I created a proof of concept for this, where I tried to do the same to trigger for, in each case, the process scripting by sending a post message. It would only require the user to click on a button, and the function would be called. The vulnerable domain would be open, and within a few seconds, the JavaScript pop-up would appear. This vulnerability was downgraded to medium. Usually, bug bounties do not handle very nicely process scripting vulnerabilities in terms of risk rating. And I've got a nice payout for this, 3-digit payout, but their bounty table was hyping way higher rewards for such vulnerabilities. And I was kind of disappointed, but hey, this is good money. Yeah. Let's see another example of a vulnerability, one where this was not paid. In this example, we can see that at some point in the event listener, we are again redirected to a part of the message. Again, using JavaScript URLs, we could trigger a cross-site scripting vulnerability. You can see that there was an event origin check for a specific domain. So yeah, we have a cross-site scripting, but we can only trigger it from one domain, which is not really a vulnerability. But what if we can get cross-site scripting within that specific domain? Could we use that in order to trigger our vulnerability? Lucky for us, there was an iframe within the same page, and this iframe would contain a vulnerable code. You can see that part of the message would be added directly to the DOM without proper validation using the HTML jQuery function. And of course, this would result in a cross-site scripting. The triggering of this vulnerability would be something that like this. Call a function that is set to read message count and an HTML tag, and that would be it. The proof of concept for this vulnerability would imply for us to first open the trusted domain that was open in the iframe, trigger the cross-site scripting within it with a slightly different payload, one payload that would actually open our main website and exploit the vulnerability from within it. And yeah, you can see that I tried to do a little bit of base64 encryption and decryption so that I could maintain my payload in an intact form without escaping characters and so on. Long story short, I reported this, and after about 2 months, it was fixed. But I've got the lowest payout in my career, 40 euro payout, 2 digits payout, and yeah, I kindly suggested to this company to donate the money because, well, filling in the financial for this would be harder than actually getting the reward. So yeah, some vulnerabilities are not really paying that much or at all. And it really felt like this company was telling me to take a few bucks and go some other part with my vulnerabilities, because I don't really need to bother them with postMessage and cross-site communication. And what is that? Nobody cares, right? So let's change our approach a bit. We will not get into 6 figures if I continue with 2 or 3 figures, right? The problem is that until now I mentioned programs which would have a pay table similar with this one. And while you are hoping to score a critical vulnerability, you will most likely be rewarded a medium bounty, which is not that much, at least not comparing with their maximum payout. So what we need to do is to focus on programs that have bigger payouts. And there are a lot of them out there, even public ones, and even bigger payouts, depending on what you report. We have to prove that what we report is higher critical vulnerabilities, and we actually have to work with companies that are actually interested in those types of vulnerabilities, right? Otherwise, they will just not pay. If they are only interested in RCs and server security, without caring about their users' security on the client side, then they will not pay. So let's see the biggest payout so far. In this example, we had an iframe, which would take a session from the local storage and just send it to the parent without any other check. If we iframe this vulnerability, we would get the session token. In this case, the triage did not really understand the vulnerability, and they closed it as informative. After 3 months of trying them to understand this, I just decided to tell them I'll make this public because it was affecting a lot of users. And what happened is that within 24 hours, they decided to pay for the vulnerability and try to fix it. And they did so within 2 weeks. This was my highest paying vulnerability at that moment, very close to a 5-digit vulnerability payout. And yeah, I'm really proud of them for fixing this. It was an ugly one. Let's see something a bit simpler. In this example, again, the event listener would follow up a redirect. We can use the same JavaScript URL tree. This would be the proof of concept for this vulnerability. Again, we send a redirect message with JavaScript URL. And what happened is that this vulnerability was paying a 5-digit bounty for this. And no, the first digit is not 0 or 1. Yeah, so the payout was really high, basically because it was in a very trusted domain for this company. They would use this domain not only for clients but only for internal use for employees, and a lot of problems could arise from there. The next vulnerability really resembles the one from the warm-up vulnerability, if you remember it, the one that is still not fixed. Well, this one is fixed, happily. In this case, again, part of the message is used for searching a function within the window object, and after that function is found, that function executes another part of the message. And the triggering this is as simple as this. This vulnerability is in a payment flow. They are expecting something like a payment success with, well, congratulations, you paid for this successfully. And yeah, the proof of concept for this is as simple as it can get. You open the vulnerable page in a new window. In this case, you had to do a POS request to get there, but you could do that via a proxy page. And nevertheless, in less than 2 months, they again paid a very, very good bounty for this. The biggest bounty at that time, again, a 5-digit bounty. And yeah, it looks like proving that you can actually steal credit card data or user information or compromising a victim's account with this actually increases the risk rating for the vulnerability. And the last one that I want to show, this one is a little bit more complicated. Again, in a payment flow. In this case, the event listener would expect a message from the payment iframe that is embedded within the page. They would validate that the message only comes from that domain and no other domain. But they would include part of the message in payment in the HTML in a secure way, so they would have DOM cross-site scripting. The payment iframe itself would also have a similar vulnerability. They would only accept messages from the parent window, and this message would be added to the DOM in an insecure way. So at this moment, I have a trust relationship between the parent window and the iframe. One can execute cross-site scripting within the other, but I cannot really put myself in between, right? Or can I? So I decided to try to embed this payment flow in a website of my own. The idea being that after I do this, I can try to hack my own payment iframe. And from that payment iframe to move towards the targeted domain and execute this. So when I got this idea, I was really proud of myself. But yeah, again, putting it in practice thought. So let's see. We have the main website that can execute a cross-site scripting within the payment timeframe, and again the payment timeframe can execute something similar within the main website, right? So I decided to implement my own payment timeframe, and from this payment timeframe, once I get cross-site scripting in that domain, I would trigger the cross-site scripting in the main website. Easier said than done. I worked for this proof of concept for weeks, I think, mainly because implementing a payment flow is not that easy. And the proof of concept was on way more lines than I could add within a screenshot in this presentation. But the general idea is that this vulnerability was pretty well received. One company paid me again a 5-digit payout for this. And this is my biggest payout to date for a cross-site scripting vulnerability or for any other vulnerability. And not only that, this is a problem that was reoccurring for a number of other companies. Not in the exact same manner, but similar implementations were out there. And multiple other smaller payouts followed up. So this is it. In the end, I would like to show you a few bloopers that I received in the last year. For example, a duplicate, and another one, and another one, and another one, and another one. And I don't know what Bass Guitar does, but he only duplicates my findings. And in the end, sometimes even Microsoft believes that what I'm reporting are not real issues. So yeah, if you watch this so far, please focus on finding this, no matter who says that it's not worth it. Even if Microsoft says it's not worth it, just do your thing.
Thank you for doing this presentation fast. There are so many things that we would like to ask you. One of them would be, so you're making a lot of money, right? You're trying to think at bug bounties as a business. And this is, I think, something we should all learn. It's not that we just have a skill and we're having fun. We have to make a business out of this. And this is fantastic. How much time do you put into this? How much time do you work?
Well, I have to say last year was a pandemic, and with all the lockdown and everything, I had more time on my hands. Usually I spend a few hours every now and then. For some vulnerabilities, I can find them in a few minutes if I'm looking in the correct spot. For others, as in the last one, finding it and knowing how to exploit it took me days. And actually doing the exploit took me more than 1 week. Again, I'm doing this part-time, my personal time. I have a day job and wife and school and everything. So yeah, only when it's free time out there.
Thank you so much, Daniel, for being here
Thank
with
you.
us today.